Reaching Mars requires crossing an average of 225 million kilometers of empty, unforgiving space. It remains one of the most difficult logistical hurdles in exploration. Despite that distance, human interest hasn't wavered. Since 1960, space agencies have launched more than 50 separate missions toward the Red Planet. But deep space is unforgiving. Roughly half of all those missions ended in failure, leaving the space between Earth and Mars littered with dead hardware, becoming a spacecraft graveyard. Because the failure rate is so high, simply saying a country is going to Mars doesn't tell the full story. To see which agencies are actually leading, we have to look at the specific tier of mission they are attempting. This matrix shows the 4 tiers of Mars exploration: flyby, orbiter, lander, and rover. They represent an escalating ladder of difficulty. Each step up demands higher landing precision, increased funding, and a higher tolerance for mission-ending risks. Out of nearly 200 countries on Earth, only 6 space entities have ever successfully checked a box on this list. Tracking which nations have conquered which tiers reveals how the space race evolved from the two-nation Cold War monopoly into a modern global rush. At the very bottom of the ladder is the flyby. The United States secured the first success here in 1965 when NASA's Mariner 4 zipped past the planet. The Soviet Union immediately pushed for the next tier, establishing an orbit. But their early efforts were marred by a string of lost spacecraft and communication blackouts throughout the 1960s and 70s. Today, placing a spacecraft into a stable Martian orbit is the baseline requirement for international agencies. Europe achieved this in 2003 with the ESA's Mars Express and followed up in 2016 with the Trace Gas Orbiter. Then, in 2013, the Indian Space Research Organization launched the Mangalyaan mission, making India the first Asian nation to reach Mars orbit. India reached that orbital tier on their very first attempt, a success rate that few other agencies have matched. The Orbital Club grew again in 2021, when the United Arab Emirates successfully inserted their Hope Probe to monitor the Martian climate. Mastering orbital insertion broke the early two-nation monopoly, but the true test of an agency's technology is surviving atmospheric entry. Transitioning from a stable orbit to a soft touchdown on the surface requires a blistering atmospheric re-entry followed by highly automated deceleration. The Soviet Union was the first to stick a landing with the Mars 3 mission in 1971. The spacecraft touched down but stopped transmitting after a mere 20 seconds. Europe tried to establish a surface presence in 2003 with the Beagle 2. The hardware survived the descent, but its solar panels failed to fully deploy, preventing it from communicating with Earth. NASA, however, has maintained a long track record in the lander tier. They secured their first multi-year surface operations with the Viking 1 and 2 missions in 1976, and continued that streak through to the InSight lander in 2018. A stationary lander proves an agency can survive the descent, but because it lacks mobility, its scientific discovery is limited to its immediate surroundings. To truly explore, agencies must aim for the final tier. Deploying a rover is the ultimate tier of the matrix. It requires complex robotic mobility on an alien world, operated from millions of miles away. NASA kicked off this era of mobility in 1997, when the Mars Pathfinder mission delivered a small, wheeled vehicle named Sojourner onto the surface. Over the following decades, NASA achieved sustained exploration using Spirit and Opportunity, followed by the much larger Curiosity and Perseverance rovers. They even expanded the limits of this tier by achieving the first powered flight on another planet using the Ingenuity helicopter between 2021 and 2024. After decades as the only nation with active hardware on the Martian surface, the United States is now sharing the landscape. In 2021, China executed the Tianwen-1 mission. They successfully orbited the planet and then successfully dropped the Zhurong rover onto the rock. By combining those successes, China ended NASA's surface monopoly, proving that a second space agency has mastered the full exploration matrix. This final scorecard shows exactly where global spaceflight stands today. The United States and China have checked all 4 boxes, while Europe, India, and the UAE operate advanced hardware in orbit. With rovers mastered, agencies are now drafting plans for a 5th tier, complex sample return missions. NASA and China are both actively designing ways to launch Martian rocks back to Earth. At the same time, orbital science continues to advance, with India studying a more capable Mangalyaan 2 mission and ESA continuing its ExoMars program. Private industry has also entered the equation. SpaceX is currently developing massive, super heavy launch vehicles with the specific long-term goal of human settlement. Mars is now a highly active global frontier, where a growing fleet of probes and rovers are laying the groundwork for humanity's eventual arrival.